So this is 8.6. So you're gonna want to pause the video like at certain points. So like you'll pause it to do the prior knowledge check and then play it, and then for the godits also you'll pause before, because I'm just gonna move straight through. Okay, so for number one, when you're multiplying radicals, remember multiply the insides. So 4 times 4 would be radical 16, and then the square root of 16 is just 4. And then this one is that FOIL thing that we did on the last lesson. So first you're going to distribute the 2 radical 5. So 2 radical 5 times 2 radical 5. You'll multiply 2 times 2 to get 4. And then the radical 5 times radical 5 to be radical 25. And then 2 radical 5 times radical 3. You'll multiply the 5 with the 3 because they're both under a radical. So plus 2 radical 15. And then now you're going to distribute the negative radical 3. So negative radical 3 times 2 radical 5 is negative 2 radical 15. And then negative radical 3 times positive radical 3 is negative radical 9. And then just go through and simplify whatever you can. So on this one, you can take the square root of 25 to be 5. So that's 4 times 5. These are like radicals that you can combine. Positive 2 minus 2 is 0, so these cancel. And minus radical 9, square root of 9 is just 3. So you end up with 20 minus 3, which is just 17. So those ones were specifically made because you don't end up with any radicals left in your answer. So multiplying a radical times itself is basically going to cancel out the radical and just leave the number. And then here, look at the relationship between these two. So these two parentheses are basically the exact same thing, except for one has a minus and one has a plus. Okay, so that's going to be important for today. And then the radicals completely went away at the end, which is what we're going to want today. So this is called rationalizing the denominator. Basically, it's getting rid of the square root in the denominator if you have one left over. So your objective is students will be able to simplify expressions with radicals in the denominator. All right, and then here's our list of how you know something's simplified. We went over this yesterday again, and then earlier this unit, and then this isn't our focus today. This is our focus today, the third one. No radicals appear in the denominator of a fraction. So the way that you get rid of any radicals in the denominator of a fraction is you do something called rationalizing the denominator. So this right here. And we're going to start out with monomial denominators, just meaning mono means one, so just single radical denominators. And here's kind of an example of how you do it. So if you have 3 over radical 2, and you want to get rid of that radical 2 in the bottom of the fraction, basically what you're going to do is you're going to multiply the radical 2 times itself. And whatever you do to the bottom, you have to do the same exact thing to the top. So you'll multiply by radical 2 on the top or bottom. And then when you multiply those together, you'll get 3 radical 2 on the top and then radical 4 on the bottom. And then you can take the square root of 4 now, which is just 2. So now magically the radical is in the numerator, which is totally fine. It's allowed to be there. And there's none left in the denominator, which is our goal. Okay? So for the first example, we are trying to get rid of the radical in the bottom. So first what you can do, if you want to get in the habit of it, since both of these are under a square root, if you were able to reduce those with each other, you could, okay? And that might come in handy later and make it less work, but we can't. So we need to get rid of this radical 3, so we're going to multiply by radical 3, and then we have to do the exact same thing to the top. So that's going to be radical 2 times radical 3 is radical 6. Radical 3 times radical 3 is radical 9. And then the square root of 9 you can do, radical 6 over 3. And then check to make sure that this radical you can't break down and 6 you can't. So you are done there. And you cannot reduce the 6 with the 3 because the 6 is under a square root and the 3 is not. Okay? All right, next one, see if you can reduce 5 and 18 with each other. You cannot. So we're going to multiply by radical 18m on the top and bottom. So for the top, we're going to get 5 times 18 is 90. So you're going to get radical 90m. On the bottom, you're going to get 18 times 18 is radical 324. And then you have m1 and m1, so that's going to be m squared. The bottom, you can take the square root of this whole thing. That's kind of the goal. So the bottom is going to become just 18m because the square root of 324 is 18 and then half of 2 is 1. So you'll notice that like what's always going to happen is when you do this on the bottom, you're going to end up with the exact same thing that was under the square root, just like without the square root anymore. Okay? And then for this one, 90m, you can break that down to 9 times 10. And the m will have to go with the 10. So 9 and then 10m. I have to write really small. Okay, so then you're going to get 3 radical 10m over 18m. And then, so you're not allowed to simplify the 10m with any of the stuff on the bottom because the 10m's under a radical, but the 3 you can because it's outside and the bottom's outside. So the 3 and the 18 you could reduce to be 1 over 6. So your final answer is just going to be radical 10m over 6m. And you're really going to want to reduce the 10 and the 6 and cancel out the m's, but you cannot do that because one's in a radical, one's not. And then for the last one, remember that if you have a big square root, that's the same as having 2 little ones. And then you can't reduce anything inside. So that's going to be radical 7s over radical 3. That kind of looks like a 5. Okay. So then you're going to multiply by radical 3 on the top and the bottom. So that's going to be radical 21s over radical 9, which is just 3. So radical 21s over 3. And then you're not allowed to simplify those because the 3 is not in a radical. And 21 you cannot break down at all, and the s is just a single s, so there's no groups of 2 that we could pull out or anything. So that's going to be done right there. All right, moving on to, so you might want to pause the video to do the extra practice, and then you can check it. But for the first one, you cannot reduce 3 and 7 at all, so we're going to multiply by radical 7 on the top and bottom. So that's going to be radical 21 over radical 49. So that's going to be radical 21 over just 7 when you take the square root of 49. 21 you can't break down at all, and you're not allowed to reduce those because they're not both under or both not under. Then on B, you can't reduce 7 with 8n at all, so do times radical 8n. So you're going to get radical 56n over. So at this point, guys, I want you to understand that like the radical is just going to go away, cancel out, and just make this go straight to just being 8n without a radical, instead of doing radical 64n squared and then taking the square root to get back here anyway, okay? So now the only thing that we could do left is try to break down 56. So let's see. Yeah, so 56 breaks into 4 and 14. So we'll do radical 4, radical 14n, because it's just a 1. You can't put it in the first one yet. So 8n. So that's going to be 2 radical 14n over 8n. And so the 2 and the 8 we could reduce because they're both outside now. So that's going to be 1 over 4. So your final answer is just going to be radical 14n over 4n. So remember, our whole goal is just to get the radical in the bottom of the fraction to be gone. Okay? All right, so now that's for if you have just like single radicals in the bottom. So now we're going to look at how to rationalize the denominator for binomial denominators, meaning you have two things, like you have an addition or subtraction between two things. So what we do for those is if we look back to the warm-up, we are going to basically do this. So we're going to use the same thing but with the opposite sign because that causes the radical to completely go away. So those two things are called conjugate pairs. Right here. So like a plus b and a minus b. So if you have the same exact thing but one addition and one subtraction, and we use those to rationalize for this kind. So first thing we're going to do is just talk about like what is the conjugate pair. So for x plus 4, the conjugate pair would be x minus 4. Radical 7 minus 2 would be radical 7 plus 2. Radical 5 minus radical 3. Radical 5 plus radical 3. Negative 3 plus radical 8. Negative 3 minus radical 8. And then for the extra practice, you're only changing the sign in the middle. And then for the extra practice, for radical 5 plus radical 3, it's radical 5 minus radical 3. 4 minus radical 11, it's 4 plus radical 11. And then let's move on to actually now rationalize the denominator. All right, so example 3, we're trying to get rid of all the radicals in the bottom of the fraction. So we're going to multiply by the conjugate pair of the bottom. So I like to put this in parentheses like that, and then you're going to add on another set of parentheses of the conjugate pair. So radical 7 plus radical 2. And you always have to multiply the top by the exact same thing as the bottom. So multiply this by radical 7 plus radical 2. So on the top, you're just going to distribute. So 10 times radical 7 is going to be 10 radical 7. 10 times radical 2 is plus 10 radical 2. Because the 10 is not in a radical, so it can't actually multiply to the inside. Okay, and then on the bottom, you have to FOIL. So distribute the first one and then distribute the second one. So radical 7 times radical 7 is radical 49. And then radical 7 times radical 2 is plus radical 14. And then distribute the negative radical 2. So negative radical 2 times radical 7, negative radical 14. Negative radical 2 times radical 2 is negative radical 4. And then we can start simplifying stuff. The top, you can't break down either of those radicals or anything, so just keep it the same. And then on the bottom, the square root of 49 is 7. These are like radicals in the middle. Positive radical 14 and negative radical 14 cancel out. And then minus square root of 4, which is 2. So you'll have 10 radical 7 plus 10 radical 2 over 7 minus 2, which is 5. And then as far as simplifying goes, if you're going to simplify and you have like addition or subtraction, like multiple things, you have to be able to simplify all three of these pieces together by the same thing, okay? So if just these two you could simplify, you couldn't do it. It has to be to everything. In this case, we can, because 5, 10, and 10 are all outside the radical and all divisible by 5. So we will divide all those by 5. So you'll end up with just 2 radical 7 plus 2 radical 2, and that's it because it's over 1, so you don't need the over 1. And those are not like radicals, and those can't be simplified, so you're done there. All right, for the extra practice, multiply by the conjugate pair of the bottom. So you'll multiply by radical 10 minus radical 5. All right, on the top, distribute the negative 3. Negative 3 times radical 10. Negative 3 radical 10. Negative 3 times negative radical 5 is positive 3 radical 5. And then FOIL the bottom. Radical 10 times radical 10 is radical 100. Radical 10 times negative radical 5 is negative radical 50. Radical 5 times radical 10 is positive radical 50. And then radical 5 times negative radical 5 is negative radical 25. All right, radical 100 is just 10. The middles are like terms and they cancel out. That should happen every single time that you're doing this. That's kind of like the point of why we're doing it. And then minus square root of 25 is 5. So negative 3 radical 10 plus 3 radical 5 over 5. And then the 3, 3, and 5 can't all reduce together, so you're done there. All right. Next one's the same kind of deal. Multiply by the conjugate pair on the bottom. So the conjugate pair of the bottom is going to be 3 plus radical 5. So you'll just have to FOIL on both the top and bottom on this one. All right, for the top, 2 times 3 is 6. And 2 times radical 5 to radical 5. And then distribute the radical 5 times 3. 3 radical 5. Radical 5 times radical 5 is radical 25. Okay, the bottom, 3 times 3, 9. 3 times radical 5 is 3 radical 5. Negative radical 5 times 3, negative 3 radical 5. Negative radical 5 times radical 5, negative radical 25. It is important to note here that you cannot just randomly cancel stuff out vertically here, like the radical 25s. No, you cannot do that. You can't do that if there's addition and subtraction in your problem. Only if it's all being multiplied together can you cancel stuff out, okay? All right, top 6. We have like radicals in the middle, 2 radical 5 plus 3 radical 5, 5 radical 5, plus square root of 25, which is 5. The bottom 9, 3 radical 5 minus 3 radical 5 cancels, minus the square root of 25, which is 5. And then like terms on the top, 6 and 5, 11 plus 5 radical 5 over 9 minus 5, which is 4. And you cannot reduce 11, 5, and 4 all together, so you are done there. All right, moving on. Last one. So you should be multiplying top and bottom by 7 minus radical 3. All right, top radical 3 times 7, 7 radical 3. Radical 3 times negative radical 3, negative radical 9. 5 times 7 is 35. And 5 times negative radical 3 is negative 5 radical 3. Okay, bottom, 7 times 7 is 49. 7 times negative radical 3, negative 7 radical 3. Radical 3 times 7, positive 7 radical 3. Radical 3 times negative radical 3, negative radical 9. All right, here I have like terms on the top. 7 radical 3 minus 5 radical 3 is 2 radical 3. And then I have minus radical 9, which is 3, and plus 35 still. On the bottom, 49, negative 7 and positive 7 will cancel like they're supposed to. Minus radical 9, which is 3. All right, on the top I have like terms negative 3 and 35. So 2 radical 3, that's going to be 32 plus 32. 49 minus 3 is 46. All right, and then you can reduce the 2, the 32, and the 46 all together by 2. So it's going to be 1, 16, and 23. And then I'm going to write the number first. So on all of them, pretty much all the other examples, we did the number and then the radical. I like to write it in that order because if you put that after the radical, sometimes people are just kind of messy when they write and will like make that too long, and then no one really knows if that piece is under or not under, so it's easier just to put it in front. So I'm going to put the 16, and we have plus the 1 radical 3, which is plus radical 3 over 23. All right. So I'm going to put the lesson check problems up, and then you should pause the video to actually do the lesson check because I'm going to start going over the answers right away, okay? All right, number 1 for the lesson check is radical 5 over radical 3. So you're trying to rationalize the denominator. 2 is radical 6 over radical 2n. 3, 6 over radical 7 plus 2. And then 4 is 7 minus radical 5 over 3 plus radical 5. So go ahead and pause the video and do these, and put up the answers right now. So for 1, you should get radical 15 over 3. Number 2, you get radical 3n over n. Number 3 is 2 radical 7 minus 4, or negative 4 plus 2 radical 7. Here, I'll write both of those. And then number 4 is 13 minus 5 radical 5 over